Hi, in this video, we are going to demonstrate image classification using Google Cloud AutoML Vision. The dataset we will be using in this particular video is part of Kagel's ongoing competition. It's called Cassava Leaf Disease Classification Competition. Right. So what we are going to do is we are going to take this particular dataset and we are going to use Google Cloud AutoML to build a model for us. Right, so more details about this data set. If you scroll down, this competition has around like 21,367 labeled images that are collected and crowdsourced during a survey in Uganda. And there are 5 different classes in this data set. It's a multi-class classification problem, and out of that the 4 classes are of disease category, and the 5th category indicates that the leaf is healthy. So basically we are predicting whether a leaf is healthy or a leaf has been infected. If a leaf has been infected, it falls into 4 different categories. There are in total 5 categories. If you go to this data section, basically you'll find more details about the data. There are multiple formats. There you have the TF record. If you see over here, the TF record format, and you also have the regular JPEG images. You can use TF record format if you're directly using TensorFlow. I'm going to use the images directly, not the TF record. It's a pretty large sized file, so around 5.76 GB. So I'm just going to use the train images. There's a test images data set as well, but the test images, if you scroll down, there's only one image in that. There are in total like 15,000 images is what it says, but that 15,000 images is only available when you submit this particular competition using Kaggle kernel. Since I'm going to use outside of the Kaggle kernels, I don't have access to test images, so I'll be just using the train data set and split the data into validation and test sets to evaluate my model. So that's what we will be doing over here. So now this is about the data set. Let's go to the Google Cloud Platform. So once I go to the Google Cloud Platform, basically I need to search for AI platform, and I will go and pick the AI platform unified one. So AI platform and AI platform unified are both same. The AI platform unified is the new version of AI platform, which also includes AutoML capabilities. So once I click on it, you will basically enter a dashboard screen, a similar screen that you are seeing over here, and you will have dashboard, and on the left hand side you will have other tabs. Now if you see on the left hand side, first time what I'm going to do is I'm going to go and open a notebook. Right, I'm going to use very minimal code. The code is only for preparing the data, and that is also not required, but I want to give some meaningful names to the target rather than an integer. That's how the data set is. So what I'm going to basically do is I'm going to just do some data preparation. Now going back to the Cassava leaf disease classification, if you see there's a train.csv. The train.csv has all the image names and basically the labels, and the labels are nothing but 0 to 4. That is 5 categories, just 0 to 4. I'm just going to rename the target name in such a way that the model can basically, you can interpret the model better in the AutoML that we are going to develop. So now once you are in the Google Cloud AI platform, go to notebooks. This is how you will see. I already have a notebook created, but if you want to if you don't have anything over here, you can just click on new instance and you can click on Python 3 and you can just say create. It will create a notebook instance for you. I have covered this notebook in detail in a different video. I'll put that video description in the YouTube comments below and you can watch it. But creating a notebook is just what I told you. Click on new instance and say create. You can configure what instance, you can customize it, but you can just go with the default one. Now once I have this created up and running, I'm going to do an open Jupyter Lab. And what I've done is I've created a bunch of notebooks, which I'll walk you through. Before that, like if you see, I already have all the data that is there in Kaggle over here. Now, the best and easy way to get the data is I have a notebook called Kaggle Data Download. See over here, what I'm doing is I'm directly basically calling the Kaggle command. I'm telling competition download Cassava leaf disease classification. If you go to your Kaggle here, it would have mentioned this command over here. The only thing you need to do is you need to go to your account, download the kaggle.json, so it's able to authenticate into Kaggle and download it. Right. So you can. So I just downloaded the kaggle.json and put it into a .kaggle directory inside my home folder. Now, once I run this, it's going to download the entire data. Since the data size is very big, it's going to take time. So I already downloaded it. It will download everything into a zip file. So if once I do a list, you can see like this is how the list file is. Once I have it, I'm unzipping it, and post unzip, I will get all this folder format. Whatever you saw in the Kaggle dataset window, you will get all the folders over here. I can do a quickly list command, and you can see like this is all the different folders I have. And finally, what I'm doing, in order for me to train this into a Google Cloud platform, I need to copy this into a Google storage bucket, right? Basically, the data has to be in a Google storage bucket because you're using Google. Think of Amazon, you will maybe copy it to Amazon S3 if you're using such capability, which is part of SageMaker, or in Azure, you will use Azure Blob Storage. But here I need to carry it into copy into the Google Cloud Storage. So for that, I am using this particular command, gsutil. GSUC util is an Google Storage util command line utility that is provided by Google. And what I'm telling is -m tells like do it parallelly, and telling CP is copy, and -r is recursive. Go to the train images folder on the top. Basically, train images folder has all the images, that is 21,000 odd images that they are mentioned over there is there, and copy it into an Google storage bucket. This bucket I have already created. I will show you to you. So now if you go to my storage browser, you can see a lot of buckets are there. If you don't have a bucket, you can just like create a bucket over here and give a name to it. But I just give a name and just say submit, create with the default options. But I already have a bucket created. The reason I have pre-created it, because the file size is huge, it will take a lot of time to copy it. So that's why I already created it. So this is the bucket Srivatsan project -vcm, and basically you can see there's a folder called train images. When I click on this train images, you can see like a bunch of image file that are there. That is in the Kaggle. So it's in my Google storage now. It's in basically it's in basically like Google storage, this folder Srivatsan project VCM. Now apart from that, I also have the labels.csv file, which has basically within this folder the images, what are the target categories they fall into, what are the target labels for that. This is also part of Kaggle, that is called like test train.csv. If I click on train.csv, you can see the image ID and the label. But what I'm going to do is I'm going to give a proper name to this label so that we can see it better in the Cloud AutoML console, right? And also I need to tell the exact path. So I'll be making slight modification to this train.csv. And for that, I have created a folder called data preparation HiPython notebook. Now, what I'm going to do is I'm importing pandas, and then I am reading this particular file called train.csv that is provided from Kaggle. And this is how it looks like. It has image ID and label, right? Now, what I'm going to do is in the label target label, I'm going to just give a name for it, right? If you see Kaggle, they also provided this file which says like the class 0 is nothing but cassava bacterial blight CBB, cassava brown streak, this is CBST, and that's the output they have given. So what I'm doing is I'm just creating an dictionary object for the label, which maps the integer value to the actual value. Rather than giving the whole name, I'm just giving CBB, CBST, and LT class. And then I'm going to add a new column called image path. The reason is I need to tell the exact path where these files are. So I'm adding a new path called image path. I'm giving the Google Cloud storage bucket where the image file is, and then I'm appending the image ID that's over there. So instead of having just the image ID, it will now contain the full path. So let me quickly run this one, and let's see the output so that you will get it. Now the image ID has just the image file, but here I have the entire file, entire path of the image file, which is in my Google Cloud storage bucket. That is the first thing I'm doing. The second thing what I'm going to do is I'm going to take this particular target 0, 1, 2, 3 and apply this dictionary on top of it so that we get a meaningful name over here, right? So that's why what I'm doing is I'm calling the data frame replace function. I am replacing the label and calling the label dictionary object. So it will automatically check for the index and map it and give a get a proper name to it. So this is how it will look like. Now label as instead of 0, 1, 2, 3, 4, it has the proper name. So now my file is ready. I'm just going to check the target distribution. Now this is how my target distribution. If you see like out of like 21,000 odd images, most of the images are most of the images over here are like basically in the category CMT, right? And remaining all and are pretty like balanced, except for the last one, which is pretty low. So we have a kind of imbalance scenario, right? But if you see like Kaggle competition, the metrics that is used in the competition is accuracy, even though it's imbalanced, but that's fine, right? Anyway, you are doing a relative comparison, but it's better to have a different metrics, but that's the metrics they have given. So even now, either we can just, what we can do is we can undersample this and pass it on, or I'm going to just pass it on as it is. I'm not going to do anything, right? Now this is my data frame again, and what I'm going to do is I'm going to take the image path and label column. That's it, those two columns. Instead, because this image ID is not required, I have the image path and label column. I'm just storing it as a label.csv file. I'm telling no index required, no header required, right? And then I am having it, and then I'm copying it to my, I'm copying this labels.csv file. Now label.csv file is here. This is how it looks like, the saved one, right? What I'm doing is I am basically copying it to my storage bucket, cloud storage bucket. Now once I copy it, it will go to my cloud storage bucket, and basically in the cloud storage bucket, this is the labels.csv you have. Let me refresh it, and you can basically see this is the label.csv. I already added, I've just overridden it. Now I have this file. Now the file ready. Now let's go and build a model using Google Cloud AutoML. So for that, again, I go into my AI platform window, the Google Cloud AI platform window. Now for this, what I'm going to do is first I'm going to configure my data set. I need to tell what is my data set, right? So I will click on the data set tab that you see on the left hand side. Once I click on the data set, you will be given a window. I'm going to say like create a new data set. Now again, this data set is pretty huge. So basically it's going to take some time to import. So here what I am going to do, basically I am going to tell it's a image classification problem. You can see it has images, it has tabular data, text data, and video data. It can work with any data set, but our data set is currently image. So I'm giving image. I'm telling it's a image classification multi-label problem. If you have binary problem, then select like image classification single. Basically, if you have single instance only, you can do that also. Or you have multi-label binary or multi-class, you can select this. If you have object detection, you can select this and everything, right? Image classification, I'm selecting it, and then I'm selecting a region. I'm going to select US Central Iowa and say create. Once I say create, it will go and basically go to the next screen. And in the next screen, what I'm going to do is I'm going to now, so I didn't give a name, that's why it says untitled. Let me go back and let me kind of take this out. Let me delete it, and then let me create a new one. I forgot to give a name, so let me give here cassava hyphen cassava underscore leaf underscore demo. All right, and then I will come down and say like image classification multi-label, and then let me say create. Right. So now once the data set is created, we are going to upload our images, right? There are multiple ways you do it. You can upload from your computer. You can import files also from your computer. You can upload images. If you have a file that has list of all the images, you can do that. I'm going to select import file from cloud storage because I have already put it in cloud storage. Once I have this, I'm going to go to browse, and then I'm going to go to this file labels.csv that we put it, because this has path to all the images that we want. So I'm just going to select this file and say select. Now I have this file. Now the data split, you can give automatic, or you can have multiple files. You can say that is a training, this is a validation, this is a test. You can configure, but I'm going to say automatic because I don't have separate data set. It's going to take a split automatically from this. You can also in your file labels.csv have the first column which will tell this image is for training, this image is for validation and all, but I'm just going to give it as it is and say automatic, and I'm going to say continue. Now, once I say continue, this is going to import the data set. Remember, this data set is very big, so it's going to take some time. Now, what I'm going to do, I'm going to go back and show you a data set that I already imported. That's over here. Now, if you see, typically a Google Cloud AutoML needs 100 images at least to build a good model, at least 100 images per class, right? But we have a lot of images. Now if you see, this is how the once the images is imported, this is how it will look like. The good thing about this is basically you can, if you go to import, if you want to add more data in the future, you can just go and add more data to it. You can select and add more data to it. You don't have to do it from beginning, because sometimes when you're running an image classification model, you may work on some data, you will feel you need more data, you can collect more data and add it and append it to the existing one, right? Now the next one is, some of your labels need not be, some of the images need not be labeled at all. You can label it here, right? So what you can do is you can just add a new label. Say if you're adding some more images with a new label with a sixth class, I can upload the images and it will come as unlabeled over here. Now we don't have anything unlabeled, we have everything labeled, and you can select it and basically you can just click on it to label it. Now for example, like this is a labeled image, right? I will click on this. This is by default in the CMD class. You can view the image and everything. I can also select like, okay, this is not CMD, let me make it LT. So you can do that as well, but you're actually CMD, so I'm going back to it. You can change your label. If you feel your lot of images and everything, what you can do is you can basically also, sorry, disclose, you can basically also create a labeling task. So what you're telling is you are creating a labeling task and asking Google in the back end to label it for you. They have a lot of manual labelers and they will do it for you. So there are multiple options available. You can label it by yourself here, but if you have thousands or kind of higher 100,000 images, if you put it tiresome, you can just create a labeling task and you can assign it to Google so that they can label it and give it to you. So all of these are labeled there, nothing is unlabeled. You can see all the counts and everything. If you go to analyze, you can basically see how the distribution is. If you see, most of our data is over here, it's slightly imbalanced. We don't have custom labels data split because we are not given anything in the image. Now this is the first thing. Now that you have uploaded this image, if you go again, this is still running, it will take around 15 to 20 minutes to load all this 1.5 GB or 2 GB of data that we have in the images, right? So here I have this one. Now I can go and say train the model. If you see the link on the top, you have the train the model. Click on this train on the model. Now it will automatically populate with cassava leaf and all this thing. You can tell AutoML. Now if you want to train on a regular prediction, you can use AutoML. If you want to do like edge prediction, you can say AutoML edge, or you can even give your custom model here with the data set. You can run your custom model also, right? But I'm going to go with the AutoML. If you want to deploy on edge devices, you can also use like AutoML edge here. Now once I have this, I'm going to say continue. Now I am going to say like cassava leaf model, and then in the advanced option, it will by default take 80-10-10 split. If you want to change the split, you can say change it. Say for example, if I want to do 75 basically or maybe 70-15-15, you can do that as well. Let me do 70 15 and 15, and then I can just say continue, right? And I can give my budget, how many max hours you want to run. So minimum is 8 hours, so I can say run it for 8 hours, but enable early stopping. So for this model, it's going to take around 30 minutes to run, but you can you want to constrain it. You don't want to run it for say 24 hours or 2 days or 3 days. If you have very complex data set, then you can just set a budget and then say enable early stopping. If it's fine that it's not the model is not improved, then basically it will disconnect at the same time. Okay, so that's why this enable early stopping is. Now once I have this, I'm just telling start training, and now it's going to go take this data set, it's going to start training. You can see it has started the training. You can see on the top it has started the training basically, right? Now to monitor the progress of it, you go into the training tab. In the training tab, you will see this is the one that we have started. It started last 4 seconds back, and it will train, and once it is complete, it will send you an email, or you can come back and check. It will show succeeded status. Now let me go to a model, the same model that I have already trained. The reason it's going to take 30 minutes, the last run took 34 minutes, right? So yeah, I'm going to go to the one that is trained and show you how it looks like post it is trained. So let me click on here. And once the training is complete, you're going to see all the labels, you're going to see your metrics. The average precision is 87%, the precision is 83.8 percent, and the recall is 72.2%. And you can see basically the split of all the train test images. We had 70, 15, 15. And then you can see basically the curve, the precision recall curve. And you can see the precision recall at zero point 0.5 threshold. You can even adjust the threshold here and basically see how it looks like. You can do anything you want. And this is basically the precision recall confidence interval, how it looks like. Below you can see the confusion matrix. Right now, this is a good way to at least run in the beginning and see how your model performs. Sometimes maybe your classes that are pretty low might not be able to recognize better or is confused, right? So the confusion matrix here says the CMD, which is the majority class, is basically 95% accurate, right? It is able to predict 95% correctly. That's CMD is the majority class. Then if you see over here, even the LT class 62% has done well, but the major, it has confused 20% to CMD. And the CGM 47% has done right. The CBB has been pretty bad, 32% only it has done right, and out of that 40% has confused to LT class. Maybe it does not have enough. If you see, CBB is the lowest of all. Maybe it does not have enough instances. Maybe we need to upload more data. Now, even if you go to Kaggle, currently the competition is still 2 months open, but the leaderboard is around 90% accurate. This classification problem is little challenging, but we can go back, work on the data, and then we can upload the data, and we can kind of see how it performs, right? Or we can do more of data preparation and also feed it. There are multiple options available. So this is how the confusion matrix looks like. Now think like we are fine with it, we can go back and iterate it. If we are fine with it, what we are just going to do is we are just going to go and say deploy and test. Okay, now once I do a deploy and test, what I can do is I can just say deploy to endpoint. Now in the deploy to endpoint, I just give a name, say cassava I underscore deploy, and then I am telling how I want to split my traffic. Now you can have multiple instances of the model. You can say I want 50% to model A, 50% to model B. I can say 100%. I am just going to say 100% over here. And how many compute nodes I need to run it. I can say 1, 10, 20. So basically, if you are to handle say thousands of TPS per second, you want to maybe have a higher number of compute node. So the traffic is split and it's basically giving you inference, right? And basically the once I say continue over here, it will I will just say one node. Once I say continue over here, it's just going to tell which region you want, and you can say I'm just given US Central and Iowa, and you can say deploy, right? Now again, this is going to take around 10 to 15 minutes to deploy the model. What I've done is I've already deployed it. You can see over here. Now this is how the model is deployed, and once you click on it, you can also deploy it for batch prediction. Here are done for online real-time prediction, right? And it will tell you all the volume, how it is and everything. It will give you a lot of information about the model. And let me go back to test this model. What I can do is I can, if you click on the sample request, it will tell you how to call it with the REST API. You can just set this and call the curl command to do it, or you can use Python. It will give you the Python program itself. Just copy paste the Python program, install the Google Cloud AI platform package, and then you can start inferencing it. So everything is already available. You don't have to write an extra code to do it. The other option is to test it. You can just upload an image. I'm just going to click this and select the image from here, upload image. And basically what you can see, basically this is the uploaded image, and it's telling this belongs to the majority is it belongs to CBSD, right? So you can quickly test it as well, or you can just use the Python program to call it, or an just a REST command to call it, or you can also have your own application that calls this REST function and gives you a response back. So the model property just shows you all the models and all the details of it. What you saw here is how easy it is to take a image set and quickly build a model and deploy it and serve it. Frankly speaking, you don't have to be an expert data scientist. If you have some knowledge on image classification, you can just do a lot of, you can work more on the data preparation and other aspect of it and leave the modeling part to here. You can also bring your custom model. That is the major advantage, right? So what I can do is, like, I know basically these are the kind of convolutional layers I want, these are the kind of filters I want, these are the kind of activation function I want. I want to use a different technique altogether. I can bring my own custom code. I can just feed it over there and I can quickly train and basically run it. It simplifies your complete MLOps pipeline from getting the image, preparing the data till deploying it, right? So that's what you saw over here. And the endpoint, basically you can click on endpoints where you can see the endpoint that is deployed. So that's about it. This Google Cloud AutoML Vision. Thank you. We will meet next video in one more Google Cloud AutoML Vision, but for text data. Thank you very much.